Excuse me. Hello, hello. Let us continue. Okay. Yeah, sorry. Right. Okay, so I went ahead and started on 4 loops here. Last time... Oh yeah, I also made these. I made these. If... So last time we did like ifs. So if echo true, else echo false. I actually never tried the else if. Let's do a little bit more interesting, I guess. So x is 5. If x is less than 6, true. Oh, failed to parse. Okay, well this is interesting. So this is supposed to... I wonder if this works. So because we're supposed to read an expression here, but obviously it didn't. Okay, that worked. True. Hello, Abduus. Welcome. Welcome, welcome. Okay, so x is... So this expression didn't work. Did you add if else? Yes. But this works. So there's a bug here. I want this to work, but I also realized that if we read an expression from here, it's gonna kind of fail over here maybe. But I like when you can have an if without parentheses. Maybe this is becoming like context dependent. A new thing that I learned. Let's see, if x equals to 5, we say that x is less than 6, x is equal to 5, else if x is more than... Well, let's just use 5 here. If x is less than 5, then that's true. And here we shouldn't get to. Okay, x is 5, so let's set x to 4. Now x is less than 5, set an x to 6. Now x is more than 5. So yeah, else if works. I'm gonna try reading but I think it will fail over here. I'm gonna try see if I can make this work here. It's the parser that needs to be fixed. So time you two working very well. Hope you finished on one day. Yeah, thank you. I'm not sure how much I'm gonna do at this point. I'm gonna work on this until it works well enough for me to personally replace bash, my bash scripts, which are not very complicated. So we're probably soon there, to be honest. I just need to add a couple more things. one of the things that I want to add as well, that's already like the pipelines. Well, the functions need to be upgraded, so to speak. The pipelines like this, like echo hello into cat or whatever, or you know, something like this. Like these ones need to be fixed because right now this works. However, if you have something like this, tail f log or server.log, and right now we also have to have them in quotes. But if we do this and then like I don't know, we grep error, and we do something else. So this does not work. Also we don't have like redirections, but this does not work because it's gonna wait until tail is done. So we don't have like streaming pipes right now. So that is one thing that I would need to fix, I think, which yeah, makes it a lot more useful. So this will just hang over here until you like cancel, like do an interruption. But yeah, hello Con, welcome. Okay, so let's see if we can fix this one. We're trying to read this expression here, but it only works with parentheses. But I'm gonna see if we can just try to make it work. I was doing for loops now, but I was just showing the ifs and what we did like last time. Yeah, this just reads an expression, so I'm not sure why it stops at the identifier. Because we should be trying... the binary is over here. Maybe we should try binary first. Because, yeah, identifier is gonna go in here. And then actually we are trying a binary expression here. Oh, I think it fails though. I think the binary fails because we are reaching a right brace, which is like a... or a left brace, actually. We're reaching a left brace. Yeah. So that is now... okay. A little bit of... I mean, I guess I don't mind having parentheses. It would be nice if you could live without them. Another thing that I did also off stream was this. So now you can have like scopes. You can have a scope like this, but this scope wouldn't be... it's not like a sub shell in... it's more like it's, you know, in a programming sense, it's its own scope. The environment variables are still gonna be some kind of global thing. So this is not like a sub shell. If we run this, we should just see hello here. So it's basically if you define a variable in here, that should work. Okay, but then you try to use it out here, and it should not work. Yeah, file not found. So it didn't even find the identifier, so it tried to run it as a command, like an executable, which results in a file not found. I should really change that message because it's kind of confusing. But yeah. So that's cool. That was actually pretty easy to add, since we already had functions being ran in its own context. I just had to adapt it a little bit, and now we have these blocks that can run in its own context. Also, what's kind of cool is that it's kind of like a function. It's kind of like an anonymous function almost, with no arguments. Because technically, once we implement standard in, and I'm thinking I'm gonna do something like this, like I'm gonna have some kind of symbol standard in like this that you can use to grab whatever standard in is in this context and do something with it, like pipe it into, I don't know, something. So this is gonna be some kind of, this is gonna be like a, I don't know, it's gonna be some kind of like a stream. Although it's like untyped right now, it's probably gonna be a string implicitly, and then you're supposed to be able to type it as well. So maybe we'll do something like, I don't know, you know, you can type it. Now we have a typed standard in, for example. I've been thinking a little bit on how to actually do this. But yeah, and also the outermost scope is also kind of like a, you know, function. However, we don't really have like a way to you know, define arguments right now. I think what I want to do is basically at the top of the file you have to have a little section, a special section where you can define kind of like the types of the arguments if you're gonna use it as a runic function. I wonder how this will play out, like if you're trying to just run this. Like, let's say it's something like this, like config, or, I don't know, runic. I'm not sure, really, what it's supposed to be like. But then it's basically standard in is an int, standard out is string or something, and then you know, arg0, I'm not sure exactly, args tuple int, let's say something like this. And then, because then what the thing is, like if you have another file that tries to like run this, so let's say we do like runic test rn, but now we have to provide an integer. So basically, let's say you do this, parse int into here, and parse in would take a string and turn it into an int. We pass it into there. So for somehow, I think that if you run a runic file, like yeah, we have to figure out how to fix this, and then what you get out is a string. So this would be the result, and then you can also pass arguments here, so the arguments has to be ints now. So let's do like 3 and 6, and let's say, you know, for example, this could be max. So you would get the maximum value out. So then the result here is gonna be, you know, 6. Oh wait, yeah, but the standard in doesn't make sense now. But it's just another way to get some input there. I guess the 5 could be, maybe we'll do something like that. I don't know. And then this would be 5. Because you're like max 3, and then the standard in is like going in from here. Something like this. So because it's kind of like, because the functions in runic is gonna have standard in, standard out arguments. It's probably not gonna have a return type. The return type is probably gonna be the standard out. We're gonna have to Well, and then we'll see how feasible that will be to work with. Hello, Borochecker. Welcome. And then the whole point of here, the config here, is that the main Runic file is also kind of like a function in Runic. It's a function in Runic, so it's actually not really like Zig. I wanted first to make it like Zig, like you import a file, that file is now a struct that you can call the functions on. However, Zig has a different execution flow or whatever. You have to, like, executions only happen in functions. So this is more like a Python module. Like Python modules work like this. You import a Python module and it actually runs the code in the Python module. But the difference here is that you're gonna be able to like pass functions into it as well. So maybe it's not Runic, maybe it's like import. Maybe import actually just runs this as a function and passes things in. You can pass standard into it. Or if you want to have it as like a reference, maybe you can do something like this. Max equals import max rn as a reference, and that would actually now reference the function that rn is, like max rn is. Something like this. And then you can use max as like as a function here instead. Maybe. We'll see. All right, but that is, yeah, this is a little bit, let's put this into like, yeah, Runic, so rn Runic as functions. Okay, we're designing the language as we go here. Right, so all this should work right now. Oh, this one is okay. Yeah. Okay. We have the blocks, we have the if else. Now I'm working on the, well, I was checking if we could have this kind of expression, but that requires us to kind of, I guess we'll keep the expression if we have a left brace here. It's kind of like a terminator for us. Yeah, I guess we'll try it and see. I'm not sure how this will play out, like, in the rest of the parsing. I guess we'll find out. So terminator is terminator. I'm also gonna do expression terminator. I mean, is left brace an expression terminator then? Probably, because it could also be its own expression, like it's a block expression, of course. Yeah, let's add it here and we'll see what kind of crazy things will happen here. Got an error somewhere, somehow. And why is it showing up? There we go. Function on. Oh, I see. I have. Okay. I have all these things here. I think I'm gonna just disable this for now, because I'm currently doing loops. We'll do that after. Yeah, we don't have for statements. I will comment this out. I changed it to an expression instead. Yeah, I'll just add it here somewhere. Okay, now it seems to have calmed down. Okay, it works now. Great. So now we can have these expressions. You don't have to have parentheses here. I'm not sure what kind of implications this would have on like other types of things. But yeah, these now counts as end of expression terminators. So great. I also thought about this, like if you have a block and then you can pipe it potentially like into something else. So you can have this as a part of a pipe. So whatever's put out from here, you can pipe it into something else. Or you could also do this, technically. Because this will be, yeah, now it won't print it. Except, oh, duplicate binding. It won't print it because now it's assigned to a variable. However, I can print it over here. Oh, yeah, so that works. Cool. Okay, let's do for loops now. Let's see. Parser. Yeah, I was doing this. So we have a for expression. And we already have like the basics here. So we have the for token, and it's gonna be a zig style for loop. So basically you have except the, we don't have parentheses. So first you parse the sources, which is a comma separated list of, lists of things or ranges that you want to iterate over. And then we have the capture. So basically it's going to look like this: 4 items, and then you get item capture, and then you have like, some kind of expression, a block here. I guess we don't. I guess we could also have a one-time expression, like every time. Yeah, and the ifs also need to support that. We don't have that yet, but let's start with the block because we already have it. So we have this block, and inside this block, this item should be now, in the scope. That's not implemented yet, but this is how it's supposed to work. And then also, if you have like multiple things, you have a range here. Then you get the IR, just like in Zig, except we don't have parentheses around here. I guess we maybe could have like an optional parentheses or something. I don't know. Now, let's start without. Okay. I'll do some examples here. So the sources is this. So it's a comma separated list of expressions that are specifically for, you know, for loops. The ranges, I mean, the range is also going to be used for slices. So we should probably have that as its own thing. Yes, it's a zig-like bash language, that's right. Because I love Zig, and yeah, I want to I want to have a bash-like language with Zig syntax. Okay, so items, yeah, that's just an identifier, and then this is like a range. So basically, we're gonna have. That's why we need a special kind of parser here, because it's gonna be able to parse both, you know, just expressions and also these ranges here, which is not a common expression. I don't think we're supposed to be able to put a range in a variable. I mean, technically we could probably try to do that as well, I mean, but it would be kind of weird. Let's just start here for now. I guess it would kind of be cool if you're gonna, like, will you decide the range before in like an if structure, and then you just put the range in, I don't know. Well, okay. Anyway, well, okay, yeah, except for in this case, in this specific case, you can't actually change this too much. I think you have to have like 0 point dot dot or 0 dot dot and then items length if you actually want it, because they have to have the same amount of well, actually in Zig that's how it works. They have to have the same amount of items, I think, otherwise there's like an error, I think. I'm not sure, because you can have runtime known lengths, or maybe there's like a safety check for that. I don't remember. Anyway, let's just start by doing parsing source. So basically it's gonna be a list separated by commas of expressions until we reach a capture clause. So we're basically gonna parse until I'm gonna take this or maybe this, modify, so we don't actually want to skip. Yeah, maybe we will have an options. Parse skip options. Yeah, the syntax is messed up because there's some kind of syntax error somewhere. And here we will have yeah, skip new lines, I think. Yeah, skip new lines is a bool, and we set it to true, I guess, or false maybe. And then here we have like if options, skip new lines, we do that. Right, so now we can use this for both purposes, and we'll rename you to parse and skip, parse until. And it also has like delimiters. Parse parse with delimiter, I guess. Yeah, so this is the result list type, like item type in the list. This is like the delimiter. So we're gonna have a comma here, And then we have the parser function, which is going to be like parse expression. And then we have the options if you want to skip new lines or not. Okay, cool. Now you will be parse with the limiter until self, of course. The type is going to be AST expression. The limiter is going to be a comma. The parser function is parse expression. Actually, it's going to be parse for source. And then this we don't need to do anything with. Okay, and that is going to be the sources that we return. We just return this. We don't need to try if we return. There we go. Now we need the parse for source. Which is gonna return an expression. Wait, it's not const, I don't think. Okay. Now, this could either be just a normal expression, or it can be the range. So I think we're gonna try to do a range first. Also, I'm not sure if you're gonna be able to put anything else in here. Like, I think this is always gonna be an actual literal number. I'm not sure if you're gonna be able to put something else in. Let's just start with that. So this is gonna be basically like, you know, expression or you know, this or this. I wonder if I should have like a notation for like element of natural numbers or something like that. No, but yeah. So there we go. And then this is gonna be, we get it. Well, let's do a breadcrumb, I guess. So first we'll try to do a range. So we're gonna do like if parse maybe range, and we get the range and we return the range. Actually, we could just return this, or if that fails, we just return parse expression. Okay, and now we need a parse maybe range. Which is going to be a nullable expression. Now we don't have range expressions yet, but I guess we'll have to just add it. Okay. Okay. Now, yeah, so this one would just be, yeah, okay, breadcrumb. And then we need like a literal number first, because you're not going to be able to have like, yeah, it's good to add these, I think. You're not going to be able to have this expression. That doesn't make any sense. Where would you start? Well, I guess it could be implied that it's 0, but because this implies it's the end. No. Let's not do that. Okay, So the first one is always going to be a number. That's good. So start is going to be parse literal, string literal. Let's do integer literal, which we don't have, so we need to make it. Here we could, I think we just do like number or integer literal. And we get the integer. It's gonna be expect token integer int literal. And then we return from token integer, which we don't have, so I'm gonna just quickly add that. Text is like same, span is span. Now this from token is kind of generic. We could probably, man, I'm always thinking of how to generalize things. I have to stop it and just. Because it's not always a good thing to generalize, especially when you don't have good tools to do it. Okay, so we have this integer now, right? And then we will say, now we need 2 dots, so we don't need any, so expect a dot, dot, 2 dots. Okay, and then we may have another number, so I'm gonna peek on the next one, and if we have that, so basically we got end is gonna be either if next tag is equal to a int literal, then we have that. Then this is gonna be okay. First, before we do this, we need to add the range expression. Oh, there is a range. Okay, there we go. Expression. It's weird that it's called like range literal and then there's like expressions. I don't know. No, let's change this to be literals for now. We can change it later. Let's do that. Inclusive end. What? When would it be inclusive? I don't think it would be inclusive ever, right? Anyway. dot equals, is that inclusive in Zig? Or what? I'm not sure if my thing works here, but is this a valid thing? Dot exclusive dot equals inclusive. I don't find anything in Zig documentation for that. Are you sure? Or is that like a new thing, or is it an old thing, or? Because the parser also like it doesn't even know what to do with this expression here. It would only make sense for infix operators. Are you talking about like another language? Because this doesn't seem to work in Zig. Because we're not concerned about other languages here. No. I'm just joking. Yeah, but I'm basically gonna make like a zig-like language. So Zig uses dot for inclusive. I thought that was only for like switch. Ah, is that the reason why it's 3 dots? But I've only ever seen that in switches. I guess it's not common to loop inclusively. Right, I see. Is that... Can you use it in loops though? No. You can't. I mean... Okay. So, yeah, but it seems to only work in switches. If you have a switch... you know... Wait. Why is this not working? Oh, maybe because I'm doing something wrong here. Okay, switch on 5. I don't know. And then, yeah, there we go. So now we have this. This works. But this doesn't seem to work. You like dot less than versus dot approach more? That's just my preference. Ah, okay, I see. I don't know. I think it's so common to have exclusive. But I also like it when it's explicit, but it just, I don't know. I'm so used to this, just, you know what this means. Like, this is, you know, I don't know. I'm kind of on the fence, to be honest, because I do like when it's explicit, because then it's not ambiguous to what this actually means. Don't you usually have this so like this? No, wait. That. Now this is exclusive to the right. What do you think about this? Mathematical, right? It's exclusive to the right, inclusive on the left. Ah? I don't know. I'm just gonna do this. This is how I'm gonna have it. Okay. We'll see. It can always change, you know, but let's see. Dot dot. Next one could be a thing. Then it's the and. Actually, it's gonna be, if we have one. No, wait. Then we're doing like, I'm gonna say this is not an expression. So this is gonna be integer literal. So that's gonna be from token next. If we don't have one, it's gonna be null. Okay. So end is now either, if it's an int, it's the int, or it's null. And if we got it, if it's not equal to null, then we need to also consume it. Actually, we could consume it right here. Oh, you're on Odin? Okay, okay. So does Odin have like dot dot less than? Okay, and then we can return self, our expression, and this is gonna be a range. Start and so okay, I guess if it's inclusive we have to do another dot here. But it's not gonna be like in for loops, so it's kind of weird. There's like two different kinds of ranges. I would rather have it be maybe they don't allow it in for loops because that would like generate so many errors. Because if you try to be inclusive, you would you would like if you're iterating over, you know, a list, it will go beyond the list, so that will be an error. And you usually iterate to like from 0 to some kind of length, and then you would want that to be exclusive. So most of the time in for loops you probably want to be in exclusive. I mean, you want to be exclusive. However, I would like to be able to parse the range anyway. Maybe here, well, I'll just have exclusive ranges for now, and when we add it, we can do it. So basically, inclusive and is false. Range literal, and then we have span. Span is gonna start at the start and end at the end, although we don't have maybe an end. So it's either going to be end or this one, last dot. Dot dot equals and dot dot. Right. For I in 0 dot dot equals 10, 0 to 10 inclusive, slices are separated by colons. What do you mean slices separated by colons? In switch it also works, right. It's expressing less than equal 1 versus less than 1. Traditional serial. Yeah. But I'm just saying, like, it's much more common to have like exclusive, so I understand why Sig does it, and I've never felt like I'm missing something there, but yeah, you can always subtract. Okay. Okay, so now we have a range, maybe. However, there's a thing here, because this might fail, and in case it fails, we want to roll back and return a null. So at every step of the way here, we have to basically roll back. So the way we do it is that we take a snapshot here, which we wait. No, not that. We do take snapshot. Oh yeah, it has to be a var. That's right. Var take snapshot, and then we have to deinitialize it at the end. Now, if something goes wrong in here, we want to return null. So basically, actually, you know what? Let's just make this function that is parse try, because this pattern is so common now. So this is like a parse error, or maybe well, it depends on the parser function. Parser, and this is any type. Oops, but self needs to be first. And this would return, let's see, where's the one-off thing? Return type. I'm just gonna make a function here that's like parser results, which takes a parser and returns the type of the result of the parser. So first we're gonna take the return type, and then we're gonna take the payload, and that is the payload. So we return the payload there. Parser payload, I guess you can call it. And we can also use it here, I guess. All right. Oh. Well, okay, let's make the payload here, parser payload. And you would be, right, you would be payload, you would be payload. There we go. Okay, now we can use, the result type is here, it's going to be parser payload of type of parser. And yeah, and now we take a snapshot. We could do a breadcrumb maybe for parse try, but yeah, sure, why not? Because it's gonna be like sprinkled everywhere probably at the end, but we can just remove it if that's gonna be annoying. So we take a snapshot, and then we do we call parser with self, and if something goes wrong, we just catch it, and then we restore the snapshot. Which can also be an error, so we have to try there, I think, yeah. And yeah, and then we return null. But if everything goes right, we can just return the parser. So now we have a parse try. It tries to do the parser. If something goes wrong, we restore it, and then we return null so that we can, so that something else can try something else. Okay. So here, for example, parse maybe range. What we'll do is we'll cut this off here, make a new parse range. Which will return an expression. And let's copy this. I need to change this name here as well. I wish there was a way to get like the current function name so you don't have to do this, but yeah. It's not that big of a deal. There we go. So now we have like maybe range, we have parse range. Parse range actually does the actual parsing here and then returns the result. If anything goes wrong, we can now do, instead of doing this manually, we can just do parse try. And I mean, technically we don't even need this function, to be honest. We can just use parse try, you know, directly instead. So we can do parse try and then parse range. And there we go. So we don't need this function at all. There's not what? Welcome, Abdul Rafi. Welcome. Yeah, we're making a bash-like scripting language called Runic. Right now I'm working on parsing ranges for the for loops. Function, let's call this parser function then. Fine. Oh, it shadows something else. Right. Okay, let's just call it T then. There we go. Member function expected 4 arguments found 3. Okay, by the way, the shadowing thing, that is one thing that I won't get from Zig into my language. Because yeah, I don't know. Maybe you can have a flag with a warning or something if it's like shadow. If you don't want shadowing and you want the compiler to tell you, maybe you can have a flag for that or something. I don't know, but I'm not gonna have that by default. Oh, I see. A way to get the current function name. So there's source returns the function name. Oh, really? I didn't know it could do that. So like this. Ah, there you go. There we go. Okay, cool. Thank you. I knew about source, but I didn't know you could get like the function. I've never really looked at it, to be honest, but okay, cool. So then we can just do create breadcrumb. No, we don't need it. Cool. Odin doesn't have allowed shadowing, which is annoying when you have multiple errors. Yeah. I don't know. I think it's good in some cases, but you know, I understand why they have it. I just don't have a. Personally, I've never had a problem with shadowing, and sometimes it feels like I should be able to do it when you can't. But whatever. Vim reggae always trips me. Yeah, I can only do like a subset of the Vim stuff, so I work with what I got. Member function expected for arguments found. Parse the limiter. Oh yeah, you need options now, so and you actually want to skip lines, so we set you to true. And where else? Whoa. Okay, right, so we still have issues here. Parse with the limiter until sources. Or until the thing. Why do you get like spanned? I see. So you get like a span for the whole thing. We don't really need that, I guess. Also, we don't actually need to pass this in now. We could pass this as an anytype. And then we can get the parser payload type of parser. So we don't need to pass in the type manually. And then we can assign T to also parser payload type of parser. Zig, you don't say it used as often due to being more expression based. When Odin's based, statement based, you end up having to name all your error bars differently. Yeah, I've come to terms with it a little bit to kind of add more context to the variable names, which I usually don't do that often. But hello, Penguin. Hello, world. Welcome. Member function expected 3 hours before. What? Oh yeah, so now we can do this and this. Okay. Now you still return like a span here. Now the span we don't need, so I'm just gonna take the payload out there. Oh yeah, you need to try. Okay, so sources equals try. Return sources payload. There we go. Expected optional found. Oh yeah, you also need to be try. There we go. Question mark? No. What? Oh. I accidentally had a store there. There we go. Okay. Oh, yeah, and you need to be a addressed. There we go. And now the ranges populate stack expression. What is this? Statement expression iterator. What? I've never seen this. Parse import. Is this even used? Oh yeah, parse import. Sorry, I thought I was in another file. Why is this here? Is this even used? What is this? Stack ex. Oh, I see. This is the expression walker. I see. Yes. Okay. Yeah. So these are not expressions anymore. So this would basically be nothing. Yeah. Because this whole thing is like it's like walking through all the different things to find all expressions. So unused capture, yeah, whatever. Yeah, I mean it's fine. I don't mind having to do that. I mean I was able to like quickly fix the issue. So really there was really no issue here. Like I understand, and it's also good that it would evaluate this first, or I mean this is kind of like implicit implicit like parentheses over here, and then or else. It would be cumbersome if you had to put parentheses here all the time. I do like being able to do this. So there we go. Yeah, so either we try to parse a range. If that fails, we try to parse an expression instead. Which, you know, a range could be an expression, but whatever. It's not right now. Well, it is part of the expression type, but it's not it's not parsed as an expression. Okay, so now we actually have one source. And this one should technically parse a bunch of sources, because that is comma separated. So yeah, right. So we have the sources, and now we have to do the capture, and the capture we already had from before. This is like the AI generated stuff. So yeah, it gives us a capture clause which has a bunch of bindings, which are binding patterns. Right, so you can discard, you can put it into an identifier, or you can deconstruct. Well, yeah, we're not supposed to deconstruct. Well, yeah. Actually, that's interesting. Deconstructing in the capture. Optional clause. This could basically, we could just say parse try capture clause and then move this here, but this is how it was before. This was implemented first and then this, so this is using this one instead. Okay, so we're picking if it's not a pipe, we return null. Then we consume that. We have the capture start, we have the bindings, we loop to parse binding patterns. This could also be like comma separated binding patterns, I guess. So really we could just do bindings equals parse with delimiter until delimiter is comma, and the parser is parse binding pattern, and we don't skip new lines. And now we can just remove this whole thing, and we don't need you. And we don't need to do this. Or actually, we have span, so this should be like payload. Okay, much easier. It's nice when you have the tools to work with. Which, yeah. That's why I like the combinatoric or whatever it's called, like the combination parser stuff. Because you have a bunch of tools and it's so easy to just combine and make the things you need. Instead of having to repeat yourself a million times. Okay. Now, yeah, so we get a bunch of bindings. We expect a pipe until what though? Wait, should we have like an ending? I guess until it doesn't find the limiter anymore. Parse. Yeah. I was thinking like, yeah, we want to parse until there's a pipe, but yeah, I was thinking like this function, if this function included the until part, like until the pipe, but it doesn't. So I don't think it's a good name because it confuses me, but whatever. So we expect a pipe, and then we don't need to do this anymore because we already own it. So bindings, payload. Yeah, because this one already does that, I'm pretty sure. Yeah. All right, and then we get a capture clause for Christmas. And oh yeah, the if also has like a thing. Okay, now we have the capture clause, we have the sources, we have the for token. So now we just, and then we have the body, that's already done. So we should technically now have for loops in express in the AST. So if we go here, and I'll just make for loops. And we have for parentheses, not allowed. I, and then, you know, echo I. Except, you know, we need some kind of end in this case, but yeah. Okay, and then we run runic print ast for loops. Oh, failed to parse. So I also did this runic log parser, so that we get parser logs when you do that. Does expect already consume the token? Yes. Okay, ignore this. Okay, so the orange means this is like the current token that we have like consumed, the most recently consumed token, and then this is like how far we've peaked. So we are now in parse4 sources. Right, parse range seems to have failed for some reason. Okay. So this fails. We don't have breadcrumbs here, so I guess we'll add one for that. Okay, do we get more information? No. Parse integer peak to. Oh wait, no wait. We should get the whole integer with this token. It's not like looking at the next like one character. We get the whole integer. Expect dot peak token if it exists. Oh wait. If so if the next token is an integer, we consume it, otherwise we don't. Right. So we should consume it at this point. And then we get the range. But something in here is wrong. Didn't it already consume the integer when trying to parse range? No, well, let's see here, because this records everything that's happening. Okay, yes, it seems so. So, wait. I'm looking at this. We're trying to parse a range at this point and parsing an integer. Now, the orange one is like the most recent consumed token. So when parse integer tries to do the next one, it should be able to get the 0 here. So there could be something else that goes wrong, and then after that it just tries to read like an expression and everything goes wrong here. Wait. Oh, and then it reads like it reads 0 as an actual like integer expression and then returns this. That should not really, well, no, yeah. I mean, we don't have semantics here, so we cannot say that. If we get an expression back, we don't analyze it and say, hey, this is wrong. You can't have this expression in the for loop because this is like, we don't even know the type right now. Well, I guess we can maybe, yeah, we can introspect it, I guess, but that's not really what we want. We want the range parsing here to succeed. So what I can see here is that, yeah, as I said, like the integer tries to read here. When it gets the next one, it is an integer, so it should succeed, but there could be something else going wrong in parse range that we don't see here. So either it's like the dot dot, maybe this is actually not dot dot, maybe there's like a dot dot, ellipsis. We could also, what you could do is log. We could do like, instead of this, we do print tokens. So we can see the actual tokens here. Okay. So it's not dot dot, it's range. This is what's it. Yeah. I didn't name this. This was AI named the thing. So, okay, let's do range. And that is the dots. Yeah, it makes sense for it to be a unique token. And then we also get a better error message, because if this fails, it's gonna say that a little bit better as well. Okay. We still get some issues. So let's see what happened now. We get the range. Yeah. So it never like restored the snapshot from this try. So that tells us that we succeeded in parsing the range. And now we're trying to parse sources. So again, the orange one is like the it's not the current one, it's like the previous consumed one. So this would be the next token to consume. Yeah, 0 could be a valid float. Yes. Well. Parse for sources. Oh yeah, so now we shouldn't have any more sources. But it should be checking for like the delimiter should be checking for a comma. Why is it trying this again? Yeah, we're passing in a comma for it to try with. So we try to parse so we pick the next if it's delimiter. Okay, that's also kind of maybe an option that we allow the delimiter at the start. If there's a delimiter, we will consume it. And wait, oh, delimiter is actually the end. Okay. So skip new lines was kind of the delimiter. I was thinking like a list delimiter. This is like the end. Okay. So it didn't really work how I thought it did. Let's just call this like until. And then skip new lines. Sure. I would like to have another version which is like parse with delimiter until, or parse with delimiter, parse list maybe. Delimiter, parser options. Yeah. We could have a kind of, maybe we could have like an optional terminator. Well, it will terminate whenever we don't find the delimiter. So let's not look at the delimiter at first. Let's try parsing first. And then we look at the delimiter. If it's not equal to the delimiter, we will, well, we don't want to consume it. Right. And then we do this. We don't care about this because yeah, we don't care about this. Okay. And maybe it should have a guard here. Well, we do have guards in the token in the Lexer, I think, for like looping too much. Okay, so basically parse list. We take in the limiter, which is a tag, like a comma or something. The parser that we want to parse between each delimiter, and then some options. And then we return a list of whatever the parser returns. Okay, we create the list here. We look at this for some reason. Open. Oh, I see, that's the span start, right? Yeah, and then the end is that. Okay. And we go through everything here. If there's new, if options, if we skip new lines, we do that. Next parser is gonna call parser. We append that. I mean, do we even need this? We can just do try parser self here. So do that. We call. We check next. If it's not the limiter, we now it's gonna be the end. Okay. So this would be parse list instead. There we go. And this is also parse list. Okay. And there we go. Now it works. Cool. So now this is like parse for sources, parse list. Why do we get this now? Parse for source. Oh, maybe it's because it's. Oh, I see. This is kind of like this is the polymorphism here. So parse list can have several, you know, instances of it depending on the type that you pass in. So this is one of the types here. It would be cool if you could see the type, or well, maybe that's too much to ask. Parse for source, yeah. So we get this for expression out, but we don't. I don't have printing for it. Let's just see if it works. Let's just try and implement it in the runner, because the runner should be saying that it doesn't support this. Yes. So let's go to evaluator. And we'll go to for. No, evaluate expression. For expression. All right. Let's just copy the if. Why not? Evaluate for expression. It exists. Good. Right. So we don't really have a condition value. I was just interested, like this. We want to run the block, but so that's why I wanted to keep. Let's just nuke this. Okay. So what do we have in the for expression? We have the body, we have the capture and the sources. So we need to somehow set this up now. Should be like in C, C++ where names are args and their types too. Well, we do. I plan on having like type inference. So everything is gonna be. I plan this to be like statically typed, but we don't really have a type checker right now. But it's gonna be statically typed and with type inference. For condition, I mean, so how it works in Zig is that you have a bunch of sources. Okay, let me see. Let me. How would we do it? We probably want to have a list. So the thing is, like, we want to basically first. The expression looks like this. Let's say you have items. So this is a usual expression. This is a kind of common pattern in Zig. You have a bunch of items, and then you have. I just meant for a log output. Oh, okay. Yeah, but I want to go through this anyway because I want to kind of think about how to do this in the actual evaluation here. So you have these bunch of things, and here you get item and I. And then you can use that. So we need to go through every source, evaluate the expression in there, and then we get whatever's in there. The range is interesting. Okay. So basically, it's like there's like different options. It's like either you could have nothing, you can have there's a bunch of different cases. Let me do this so we can separate a little bit. So this is kind of the easiest case. If you only have one range, and you have to have a binding as well. So the number of ranges or the number of sources has to match the number of ranges as well. Otherwise, I think there's going to be actually, yeah, that would be like a parse error. There could be like a parse error actually. So we don't need. So now when we get to evaluation, we can like assume that they have the same number of things. We could have maybe options in here. Or we could just inspect this. We can check if capture bindings length is not equal to sources length. We return error. For capture must match bindings or sources. Yeah, if you omit the capture, there's no need to have it in the source. Then you would have to just remove the source as well. Because there's no point, like this does this doesn't do anything if you don't capture it. You can omit it. Like you can do this though. You can say you can discard it like this. If you don't need items, for example, but you only need this, you can do this. This is supported now, because these are what's called binding patterns, and we have this as a binding pattern, which will be a discard binding pattern, so it will just discard it. So this could be a valid thing. I was thinking more like, if you remove this, well then there's no need for this, so you don't care about this. However, having items is important because it determines the length of this. Although an alternative to that is to just do dot length. Although we don't have support for expressions like this in here now, which is bad, I just realized. So we should probably have that. But yeah, Okay, so if you want to do this, you actually have to do this now. Yeah, we should definitely have. Okay, we should definitely. I should definitely take that back there. I don't know why I did that. Let's just take this back. Should both of them be expressions? Parse expression. Although this is like parse expression until ... I guess. Like with a special terminator. Maybe expression terminator ... is part of it. Alright, and then end would also be... Actually, we want to peek if it's a pipe, if it's the start of the... If this is a pipe, then it means it's the start of the capture. So we will do parse no, we don't do parse expression. We do null. Otherwise, we do parse expression. There we go. Except I just realized now we're getting into the issue where, because we're mixing bash syntax with zig syntax, you know, pipes, it doesn't mesh very good now. So maybe we should have a version of parse expression that doesn't allow pipes. Or we just add parentheses. But Yo, Yash K, how's it going? Welcome. Alright, you are spam there. Yeah, this is gonna like parse it as a pipeline. No pipelines. Import, sure. Identifier. Yeah, this is part of the pipeline here. So I think maybe we'll do like, maybe binary. It can also be member access. We don't have member access yet. Well, no, we do have member access. I'll just remove this. Because, yeah, we're gonna do it here anyway. However, okay, this is where it gets weird. Because all of these, I don't want to have, like, special versions of everything. It would be cool now if we could have, like, a context stack here, but... should we just add parentheses? Okay. Maybe I'll just add parentheses until we have this fixed. So we can move on. I mean, we could also enter like a special mode. You could have context stacks. You could have like context to say that, yeah, now we're banning pipelines in this scope, or something like that. But let's just add this. There we go. Because this is gonna be an issue when we parse a range, and at the end of the range there comes a pipe like this. Well, now there's a pipe here, but let's say this is an expression here, a range and a pipe, and this is I. So when it tries to read this expression as an expression, it's gonna try and read this as a pipeline, where I is like one of the stages and 4 is one of the stages. And then, I mean, even worse, if you have like something called echo here, or you know, length or whatever, it's gonna treat this as like a command now. But and then it's gonna fail here, I guess. But you could technically, maybe, potentially get, like, what if this was a one line and you keep going here, echo whatever. Now it treats this now as a pipeline. I guess we could kind of, when it comes back, we could ban pipelines. I don't know. But yeah, let's just add parentheses for now. A or B capture, yeah. How would 4 understand the pipeline output for it to work in a loop context? If A, B outputs a string. Well, yeah, you wouldn't have the pipeline in there. That's what I want to avoid. Like, you wouldn't, but you, like, if you have a string, like, it depends. Like, should we allow a for loop to automatically loop through like the characters of a string, for example? I mean, that could be a thing. We could treat basically strings as arrays of characters, and if you loop, you will loop over the characters in the string, for example. But I mean, if you wanted, let's say you wanted to have, you know, let's say you have like, I don't know, cat and then some log file, and then you want to loop through the lines, you could do then 2 lines or something, which could be a built-in function or a function you made yourself that takes a string and puts it and then the result is a bunch of an array of strings. No, but there wouldn't be a delimiter. If like if you would for loop over a string, there wouldn't be a delimiter. The delimiter wouldn't exist. It would just be looping through all the individual bytes of the array. Yeah, there's gonna probably be some kind of construct you could do to easily do what I said here. Like if items is a string and you want to make it lines, you have this function 2 lines, and let's say you have this function 2 lines. Now I'm not sure about the syntax, but basically it's gonna take in a string 2 lines and it's gonna output an array of strings, and then it does that somehow. Yeah, if you have an array, we're gonna be it's gonna be treated as an iterator. Like, or yeah, it's just gonna iterate over the array. Because the functions in Runic is gonna be, they are very much like, you know, programs that you call in Bash. Basically, they are not gonna be the classical functional or like programming functions. They are gonna be they're gonna mimic you know, processes that you call, and you can have like standard in, standard out, standard er. But also it will be cool, and if I can make this to that so that they can be typed as well. So when you're in Runic, when you're in Bash land, you know, all the process and everything, standard out, standard or whatever, they are all like strings. But in Runic land, it's actually going to be like statically typed. So it's a statically typed, you know, standard in, standard out. Which means you can do something like this. So 2 lines, string. This takes a string, returns an array of strings. And then the result will be an array of strings, which is line separated, that you loop over. And there's probably going to be structs as well, but we'll get there. Let's see, how much time do I have today? Yeah, a couple of hours more. So when you see 2 lines, a function in a pipeline, it is automatically iterator. No, it's just that it takes a string and produces an array. So basically, it's the fact that it produces an array, and the array itself is actually, you know, it can be treated as an iterator. So you're just turning a string into an array, and then you would iterate over the array. So how would you differentiate between built-in functions and external programs in that case? Because the built-in functions are gonna take precedence. So if you call something and there's a built-in function that has the same name, we're gonna pick the built-in function. If you have a program, it's not gonna be called. But I guess we could I've never thought about this actually. It's a good question. We could introduce some kind of mechanism to try and read, or I mean to try and execute a force trying to execute is as a program and not as like a function in Runic. Because now they're like interchangeable. But if you want to make sure that you're actually calling the program echo, for example, then you can then we should have like a construct for that. I think we should have some kind of expression, some kind of syntax for that. Yeah. Or if someone yeah, I mean, I don't know, it might end up that you would actually have to explicitly tell Runic that this is supposed to be a command and not a built-in function, because that could potentially catch errors where you thought you had a Runic function, or you think you have an executable, but it's actually a Runic function and it does something else. So a byte array only. Yeah, so a string is a byte array. And then, like in Zig, that's the case. Like a string is just an array of bytes. And then, you know, it's easily iterated over. And then the array is also going to be iterated over. And then we'll see what other kind of iteration, like constructs, maybe we'll get to. Yeah, so either it's going to be that executables are going to have a prefix, or the Runic functions. I'm not sure yet. Maybe none of them. We'll see. It's probably, it could be like a, yeah, I don't know. We'll see. Unicode. I'm not gonna think about that right now. It's gonna be UTF-8, but you're only allowed to use ASCII. Now, okay, so we do need parentheses now. Okay, so what is happening here? No field name span. Yeah, there we go. Okay, so now ranges are actually expressions, and we now need to go here and undo this. Oops. There we go. Easy peasy. All right. Oh yeah, now we need parentheses here. God damn it. Now there's inconsistencies in the syntax. Maybe we should just force ifs to have parentheses as well. I don't know, I just like the idea of not having to have them. Okay, that works now. So let's continue with this part. Yeah, I mean, okay, it's like this. Like, personally, I don't need anything else than ASCII, so, but, you know, there might be a good thing, I don't know. A good thing to have. Okay. Yeah, so what I was thinking here is basically we have a list of things. So we have a list of like sources and bindings, right? We need to evaluate basically all of the sources first, and then figure out the bindings there. So let's make, I guess we'll make like a list of values, sources values. Value. And we can even use like init capacity because we have for expression sources length. Oh yeah, I wanted to try this as well. So if we have, let's say we have items. Now this should also work. No? Fail to parse. Parse expression identifier. Binary should fail. Pipeline does not fail. Actually, it does fail. It fails. Wait, which one fails here? The range. Yeah, okay, that makes sense. The range fails, but then this should also fail. No, it doesn't. Yeah, okay, this is like a pipeline stage now. But it's deceiving really, because it's like the pipelines allow, like if you have one item in it with no arguments and no, it's kind of stupid how it's done, but it's like if you have one item with one stage, if you have one stage, no arguments, it's going to be treated as just the identifier being evaluated here. So that's fine. And then we're still trying to do this, so we're doing a range, except we don't consume the comma. Is that the issue here? We don't consume the comma? Yeah, that seems to be the issue. We peek. Okay, so if it's not equal to that, we return, but then we should actually consume it. There we go. Oh, and of course we have like a bunch of errors here. I'm just gonna do turn error, supported, unsupported. Yeah, whatever, it doesn't matter. There we go, now it works. Okay. Cool. So let's go back here. And what was I trying to think about? Oh yeah, so I wanted to test this. Like if you have that, we should get an error saying captures must have match sources. Yeah, cool. But let's try, I'm gonna do this first. Also, we don't have like items. We don't, yeah, I don't think we can make arrays yet. So that's also a thing. Okay, maybe we should just do this one first then. Like, just say that it's one range. Values. Deinitialize. Oh yeah, this needs to be tried. Scopes. Yeah, so now we look through all the sources. Or where is it? Force expression sources. And now we can actually do this. See, this is also what you can do in Zig. You can have two different lists. And then if, like the first one is a list of expressions, the other one is, actually I need to put items here, is a list of values. Except I don't really need to do it like this, but you can, because I can use append assume capacity. I was thinking like being a little bit cute here, but whatever. No, let's just do it the real way. Okay, so this is source as an expression. And then sources values, we can append assume capacity now. And here we're gonna do value is gonna be try self evaluate expression with the scopes expression, and we're gonna put the value in there. There we go. And we don't need to try this or anything because it assumes we have enough space, which we do. And you want to have an allocator. All right, so now we have all the sources as values. So we know, for example, what items is supposed to be. For example, we know that this is a range. However, I'm not sure if we actually have like the range like the range expression in here. No, we don't even have that. So let's do that. Evaluate range expression. So we do need this as well. Range literal, which is a weird name, I think, but whatever. I don't know the definition of literal, because to me literal always meant like it's not supposed to be like further evaluated. Like here, this includes 2 expressions. That doesn't feel like a literal to me. All right, Penguin. One second here. Okay, so what do we do here? We should have like the start. It's gonna be like range start. That's the expression. We do try evaluate that. So now we have the start. So this should be like a value. We have to now check if it's this has to be a number. This has to be an integer to be more specific. So if this is not equal to an integer, then we have to return like a type mismatch error. Okay. We don't really have good logging when it comes to the runtime errors here, but whatever. Okay, and now we have like different things here when it comes to the end, because the end could be like, if its end is null, we have to take the context into account. So basically, let's look at the value here. See, here we don't have a range value, but we need a range value now. So I'm just going to add a range value here, which is going to be, it's going to have a start, which is an integer. It's going to have an end, which is an maybe integer. And let's just have this so we support it. Okay, that's it. That's the range value. Okay, because if it's null, we will have to check for the context to be able to use it. So the actual evaluator would have to decide how to use that. But here we don't know. So here we can just return a null here. So basically now, well, actually, like if we have end, we want to also make sure it's an integer. Actually, you know what? Yeah, it's supposed to be an integer because we are evaluating the thing. So if we have an end, we will take the value here. Well, let's call this expression actually. We get the end by doing try self.expression, scopes expression. Okay, and we do the same check here. I think, do we have like expect or validate? I forgot. expect type, right? We have expect type actually. So we can do like expect type. Actually, we can do it here. Integer. And we can do the same thing here. Try expect type. Integer. It's gonna format. And then if we have an and, we can return. Actually, let's do it like this. We have like the result. It's gonna be a value, and it's gonna be range. Start is start. End is null. And this is range inclusive end. If we have an end, we now set the result to the end. If we don't do that. We just return. There we go. Okay. It's always super nice to have the option to have a mutable variable sometimes. I usually don't do that. I usually try to always have const when I can, but sometimes it's nice to have. There's probably a lot of other ways you can do it as well, but whatever. Now we have the range value, so now we can actually yeah, now we have the potential range values here as well. Now we could do what? Like after we have all those, I think we have to go through each to check. We have to do like a check for check sources. Check that all sources have the same length. So we're gonna go through source values, because otherwise it's gonna be like a in Zig. I think that's like a runtime error or something, which is not really that. I mean, we could do it differently, but I think it's probably good to have a runtime error, because you might, like if you're doing two lists and you're they don't have the same length, like what should happen? Like should it just abort when you reach the end of one list? You know, that it's like ambiguous things like that. It's better to make your own like iterator instead, and we just force everything to have the same length, I think. Okay, so this is a value. Wait, no, items. There we go. Yeah, this is the value. And we need to check. Well, first of all, they need to be like, we need to have one item in, at least one item in here, but I think we will, perhaps. You know what? Is this a valid program if we just delete that? No. Unexpected to, okay, yeah. Okay. So we'll have like expected length is gonna be, we'll just take the first one. Okay, so we don't have arrays. That's the thing. Like we don't have arrays, so we don't actually have a way to check that. Maybe we should just add arrays here now. And arrays would kind of be like strings. Strings right now, or I mean, it's kind of like an array. Strings are actually memory, it's actually like reference counted. So I think arrays will basically be the same thing. It's just going to be like a memory. It's just going to be like a value like this. So it's a reference counted array of values. However, the items inside should also, well, strings are reference counted though, so, but when this is released, we should also release like we should deinitialize the inner values as well. So maybe we need a special thing for this, or the reference counter, maybe we can have a special type here, like the reference counter, when it deinitializes, it actually tries to release the thing inside as well. So for if it's a slice, we're freeing it, but maybe we should also release, go ahead and check if any items are reference counted. We should like release them as well. So we'll do like for pointer. So that should be now the array. We get the item, and I will check if it's a ref. How do we do that? So basically we want to check like if is ref item. Well, we don't know that because we don't know if, no, we just need to deinitialize. Yeah. Actually, because the item is a value which in turn calls okay. This is kind of, you know, deep in the nest here, but if we have now, if there's a deinitialize function on this, we will call it there. Now we could also check if the params requires a deallocator or not. Maybe I should have a function. Let's make a function here. Call the init if exists. And we pass an allocator. And we pass the deinit, which is yeah, it's like an antitype, and then we are doing yeah, just void. So let's grab like t is the type of deinit. I want to check like if this is a pointer, then, well, then it doesn't matter. We could just call deinit actually anyway, or the type. We're basically checking like if has function, does this check like for pointers as well? It does not like flatten a pointer. That was my point. Let's do var maybe. Could we have var here actually? I'll do this. If type info type of, well, let's just do like no, let's just do it here. Type of DNT, and if this is a pointer, no, actually we'll just switch on it. Switch on type info type of DNT. If it's a pointer, we will do pointer child. Okay, now we can actually just do this. And we need the pointer there. Right? Otherwise, it's just gonna be DNT. So, if it's a pointer, we take the child out so we can look for the init function on it, because this doesn't take pointers into account. This just looks at the structs. Wait, but then we call this. Yeah, I'm not sure if this takes pointers into account. Let's just be safe. Also, can we get the function? Function field info has function D in it. I guess we can do info is meta field info t D in it. So now we have the info, and we can look at the params, which is going to be the info function. No? Wait. Oh, maybe this doesn't work for declarations though. No. It's gonna be T. Actually, we don't need this at all. Actually, we can just. No, we do need this. We can just say t.dnit. Okay, let's just do this. Type info. Sorry, it's a bit. And then dnit. This should reference the deinitialize function on the type. We should be able to refer to it like this. Except we need type off here. So, and then this is a function, and we're looking at the params, and if we'll grab the params so we can. So if the params length is 1 and params 0, type is equal to allocator, then we will call dnit with the allocator. Otherwise, if params length is 0, we will call dnit like this. It could also be that if it's a pointer and it like no. Yeah, this should work there. Yes. Otherwise, we're gonna do like a compile error saying that unsupported init with more than one argument or parameter. Okay. Else if. Okay. Now we get this, and if we have it, we call it. So if we don't have the init, we don't call it. So call the init if exists, I guess. We could do that. We could also return like a nullable void so that we can check like if we didn't call it, we return void if it was called, but if we didn't call, we return null. I wonder if we can use this actually, because then we can say like if we wanted to have other branches here, we could do that. But call the init if exists allocator on item. And now I will do this just in case. There we go. And then we can do the same thing here, except call the init if exists allocator so pointer. Let's do that. Because now it's like, okay, if this succeeds, we go into this branch, but otherwise we want to go into the other branches. So that's kind of why I did it like that. It kind of looks weird. I've never done this. I usually don't do this pattern before. Oh, allocator is self-allocated. Right. There we go. Also, this formatting gets messed up here. Can I do this? No. You can do that. Okay, cool. I've never done that before. Okay. Right, so we have that. Hopefully it works. I don't have tests here. I do have tests here, I mean. Oh, I see. Okay, so this doesn't work. Value of void, question mark void ignored. Oh, well, that's an easy fix. We can just say that. And we can add tests here for the other stuff as well, like the new things. Invalid free, I see. Hello, Blue. Welcome. Welcome back. How are you doing? RC free. Okay, 123. So we're there. That's invalid free. So this is ref get. Can you tell me what comes after abstract syntax tree? Well, in this case, which is a scripting language that's supposed to be ran by an interpreter, the next step is to execute the AST. So, but you know, in like, you know, C or C++ or something, you have a compile. You take the AST, you compile it to. Well, oftentimes you compile it to like an intermediate language, or the end result is an executable. So that's the difference there. Yo, try help. What's up, man? Do you usually talk in your mind when solving problems coding? I mean, I do have a voice. I hear my voice. I haven't thought about it too much. I mean, yeah, I think there's a difference when I'm talking out loud and when I'm trying to think. I think it's a little bit different, because when you're talking, it's like you're going through another process of actually trying to formulate your thoughts out loud. And that's why I think that's why the duck programming thing works, like, because you're trying to, once you have a problem, you can't solve it, then we try to ask someone else. In the process of asking, you formulate the idea into words, and then in kind of another way, I guess, and then you in that process, without actually getting an answer from the other one, you will get the answer yourself by just asking the question. So that's duck programming. And I feel like sometimes I do that here when I stream. I just talk about it and I get the answer. But I think that when I try to solve a problem, I'm just letting the mind kind of spin around until it kind of locks onto some idea. I think that's what's happening. I don't know. Yeah. Okay, what is the issue here? Yo, Vicent. Wait, oh, the test. So we're doing 202. Okay, what are we doing here? We have a string. I think it's trying to release, or I mean, yeah, I think it's trying to like deinitialize this string, maybe. Oh, it's an invalid free because this is a constant. Right, we don't have a way of checking that. Okay, yeah, but instead of init, we actually have to use dupe then. There we go. And we probably have, yeah, we need to dupe this. There we go. How do I execute an AST? I mean, it depends on what your AST has. If your AST just has a value that is an integer, I don't know. What happens when you get an integer? Do you like get the result at the end? Do you just you know, it depends on your programming language. Like, do you just want to print it to the screen, or what do you want to do with it? Or do you use it as an exit code for the program? Yo, Penguin, welcome back. You have wait, 7 stream streak going on right now. So yeah, it totally depends on what you want to do with the AST and what kind of AST you have. So for each like thing you're implementing, you have to implement how to execute it as well. All right, but let's see if we can add some tests for this now. So we have now, when you deinitialize an RC, we also call deinitialize on the items inside if we can. So let's make a new test, release or deinit children, and let's have a type here that is for testing only. So this would be like a, or actually, you know what, we could just make the type is gonna be like a list of RC, it's not const, it's like RC of, I mean, yeah, we could do strings. So we have a list of strings, So list of RC. That is a list of strings. .ref has to be .ref. And nested RCs. I'm on 12 strike. Oh, well, the Twitch doesn't report that. It only reports Penguin, I think. So something has happened there. Do you need an abstract syntax tree for Bash? I mean, technically, you don't actually need an abstract syntax tree. If you're just building an interpreter, you can just read the. I guess you could just read characters at every time, and then depending on the character that you get, you decide to do something like execute. You could build an executor. The only thing you need is an executor or interpreter, whatever you want to call it. But you know, I'm building it because it's because I want to have static analysis of the code, so that you can catch like errors and stuff, and you can get LSP help, like help with whatever type you're dealing with, or signatures, or like function signatures, documentation, or whatever. Like let's say I was thinking maybe we could extract a portion of the manual for each executable that you're trying to, like, you press information about an executable, you get the actual man document. I need 3 more days to post it. Oh, I see. So you have to post it yourself? I'm very noob at Twitch, by the way. That makes sense. Yeah. And also, like, yeah, I think it's fun. It is useful, and it's a fun process for me as well. And I'm building. I especially like this part as well. I've never done garbage collection at all, actually, and this is like my first construct with garbage collection here. It's the reference counter, and now we have a reference counter that has like a list of reference counters with a list of strings. So it's a list of strings, and I'm gonna try to create this value somehow. So we'll make a list of RCs. Let's just use an array list, I guess, for convenience. So this is going to be an RC of strings. And we will deinitialize this at the end. And then we'll append we'll do like try append Are you implementing your own ARC for your language? What made you want to add this? I'm not sure if it's an ARC, it's just an RC. I guess A stands for like async or something, I don't know. But it's just a reference counter. The reason for it was basically in the evaluation engine. The values gets tossed around from place to place. So instead of having to like manually try and find the exact place where a value should be deinitialized and released from memory, it's just a lot easier to just throw it in an RC and then just keep then just keep track of where you need to release it instead. That's a way easier problem. Oh, A stands for automatic. Okay. I'm not sure if it's automatic. I don't know if you can have that in Zig. Like automatic. If that means that you don't have to even call release on it. Because this one is basically, you can request a new reference that you then have to release at some point. Yeah, so all references need to be released manually still. But what you get is you don't have to like pinpoint exactly where the free should happen. Also, it's also good because you don't have to clone. If you have a string, you don't have to clone it everywhere as well. If you want, if that's the pattern you had like before, like you don't have to clone it, and you just can keep one copy around with a bunch of refs. Yeah, it is fun. I think it's fun anyways. Okay, so then we need a ref here, and the ref is basically, we have a convenience function called dupe, which dupes a string here. So we will have like, I don't know, the first string, the second string, and the third string. So we have 3 strings in there. And if everything goes to plan, everything should be deallocated at the end and no leaks should be reported. If anything leaks from the testing allocator, it's reported out. So if everything runs without issues, then it seems that it is working. So we have 2 refs here. We released the first one, and we're doing some checks here. Yeah, so we should be able to just run this test and get no leaks, or we can get errors as well. Oh yeah, we need try here. Oops. There we go. 243, the string found. Oh yeah. So here we need now to say RCS items instead. So they are the list of refs. There we go. Oh, we got leaks. One test did leak with a bunch of leaks. Okay. So the dupe there, and then so this dupe is from the first string. Okay, so that wasn't released. Oh, you know, well, actually, okay, okay. If you have a bunch of RCs, they don't actually have a deinitialize function. They have release, or I mean the ref actually. The ref has a release, but maybe they should be called deinitialize actually instead. Yeah, they should probably be like deinitialize actually, because it makes no sense to like force a deinitialize. And we don't have the initialize. It should just be called the initialize, to be honest. But then the RC itself has to release, so that's good. Which will just decrease the ref, and that's there we go. Okay. Yeah, that makes way more sense. These with more than one parameter. Really? Oh yeah. Wait. Okay. Actually, we need to. Okay, we need to support. Well, when we're inspecting the params, the first one can actually be the type itself, like the self type. So in a manner of different things. First, yeah, it has to be self because we're always calling with this. So actually, let's just assume that it's always that. No, we never want to date it in array. Oh, okay. We actually need to abort if this is an array. Okay. So let's do this. Let's do break. And if the size is 1, we will break this out. Otherwise, we'll return null because then we have an error there. Or then it doesn't have a deinitialize, yeah. But it was kind of weird. Oh, there we go. Nice. But it was kind of weird that it tried to call the initialize on the array. Like, it shouldn't have the function, so we shouldn't ever go in there anyway. I don't know. Okay, but it seems to work. Yo, SQF. How's it going? Welcome. Okay, so now our RC supports like deinitializing if it's an array underneath, which it should own itself, then it's also deinitializing that. It's kind of convoluted here and very specific, but if we have a slice, it deinitializes that. If the items themselves have can be deinitialized, they will be deinitialized. And then that should be now that should be like a chain reaction, because yeah, their deinitialize will, you know, automatically deinitialize. So yeah, so let's go back here. So now this array is a list, is an RC with a list of values. And should it be const actually? Yeah, maybe. Not sure. This is a pointer, so it kind of removes the constness of it. But yeah, sure. Let's have it a constant. If it becomes a problem, we'll figure it out. Because it's, yeah, it makes sense in a way that it's const because the contents shouldn't change, but then again you should be able to like de-initialize and stuff, and that might sometimes require a pointer there, but or mutable. Okay, so now all that, now we can represent arrays in values, and what we do now is here we have to get like the length of this value. So if we now go back here, let's add a convenience function here, get length, and this would return you know, a U size, and then we'll return switch. Whoops, switch. So if we are an array, we get this out, and we can just return God damn it. Wait, did I add it? Did I add the array type? No, I didn't. Okay. So it's a ref. It is fun. It's fun. It's very fun, actually. But the LSP sometimes is a little bit, yeah, not mature. But it's fine. It works for the most part. I just have like a bunch of trouble lately, like recently. I'm not sure if I need to update it or something. RCT. Yeah, no, we just call get. That's right, we call get, and we will get the value, which is an array, of course. Yes, so we get the value. Actually, we have to try, so this could be an error. And then we just do length. Yeah, if it's an array, we try to get the value out and get the length. Yeah, do it. By the way, I'm using Zig 0.15 right now. If you go to their website right now, like there's different versions, but 0.15.2 I believe is the latest release. But I also use a convenient like version manager that's called ZVM, which is really useful to install with. So I usually just use that to install the new versions. But then they also have the master version, which is currently in development 0.16, which will change things a little bit. But yeah, I use ZVM. I recommend using that for version management of Zig. Yeah, you can say that. I mean, it's not really long-standing or long-term or whatever it stands for, but it is the latest kind of stable version. Yeah, you can say that. Even though like the whole program language is kind of, I think the first version came out like 2016 or something like that. So it has been around for a while, but it's still, it's still working its way up to 1.0. But there's almost no, what I've seen, like any compiler bugs or anything like that from what I've seen. Maybe if you try to do something really fancy with the advanced things, but for normal things, it works fine. Or it works really great. Pretty new, yeah, pretty new and exciting. Okay, so length. I mean, I guess if it was anything else, like it wouldn't make sense to, we're kind of coercing, and should we coerce an integer to just be a length? Sure, why not? And we just return this integer there. Except this is an I64. Let's do if integer is less than 0, we will return some kind of error. Length is negative. Otherwise, we just return int cast integer, which will convert an integer to another integer while keeping the same numerical value. The return type is the inferred result type. Attempting to convert a number which is out of range results in a safety checked illegal behavior. To truncate significant bits, use truncate. So you could also kind of, yeah, it's gonna detect this. You're not gonna get past that anyway, probably. Okay, and if we have anything else, it's gonna be some kind of error, like invalid cannot coerce into length, coerce value. Yeah. All right. Now the length is going to be the value get length. Right. So now we can do like arrays or integers there. This is NeoVim. What do you use? Okay, so we got the expected length, which we could do a constant. Now we just want to check that all the lengths are the same. So yeah, we get the length. It's gonna be try value get length. And oh yeah, also if it's a range, we also have a length. However, in the case of a range, we need to be able to evaluate that. So maybe this isn't the best place for it. I should move this to the evaluator actually. Evaluate length of the value. Let's do self is evaluator, value is value, and we also need the scopes. Use nvchad neovim config. Okay, cool. I've never used one of those. It seems very convenient and probably a nice time saver, but I don't know. I just roll my own. Unused local constant. Yeah. Okay, I'm getting distracted by all the different things that's in progress right now. So self is not self. This is value. Okay. Now, if the value is a range and we have the start, but the end is either range and, or it's gonna be oh yeah, I guess it's null. I guess if the range is null or the length is null, we don't actually know it, so then we have to actually return null here. So basically, like if range end is null, return null. Otherwise, return range start, range end minus range start. So if we have end 1, start 0 is going to be 1, and that makes sense. Okay, theming. I don't know about that. Or I don't know anything about how to do that. Yeah, it is convenient. I mean, I guess you could always like, couldn't you always like eject from it and start like tinkering around yourself? So do they have like their own theming engine or something? Okay. A good keyboard? Yeah, maybe. I just have like a normal mechanical keyboard. Or, yeah. Now this one, so basically what this is doing here is I'm trying to check if all the, okay, let's show them here. Basically here, if you have this and all the sources here has to have the same like length. Like let's say you have like two lists of items. If they have different lengths, then this will be an error here, a runtime error. And also the range. So I'm trying to figure out the lengths of every source for here. And if the range doesn't have an end, then we return null. So that should always match. Otherwise we return like the length of this here. The integer doesn't really make sense though. I don't know what I was thinking there. The integer should just, yeah, that shouldn't be in here. There we go. I think I thought I was thinking about the range like components there or something. I don't know. Anyway, so we have that. Yeah, okay, now we need to do like try evaluate length. Or like that. So that's the expected length, except it could be null. Oh, okay. We have to find an expected length. If we have an expected length, we will alright, see you later. SQF theme plugins. So what does the theme, like, what does it do? Like that's different from you know, the built-in stuff. So we try to find the expected length. So actually let's just make this a function here. Validate for sources lengths. Oh, wait. Let's do items. No. So, and sources. Right. So if we have it, otherwise we're trying to find it. So we get the length of the current item, which should be like evaluate length, self-evaluate length, scopes, and value. Actually, we could just do null, I guess, then. So this would be like this to start with. Base 32 system with named theme tokens. And you can load themes asynchronously, part of init. Convenience for switch themes, a lot of themes for other editors. Okay. Alright. Sounds cool. Lua is way better than Vim script, or because I mean I would tend to agree. For me personally, I can understand Lua code better than Vim script, so it's a more, I guess, you know, common programming things that are in Lua contra Vim script. Yeah, some things in Vim script is easier, but you know, when you're trying to do I don't know, random stuff, you always end up having to like look up this and that. It's kind of the same problem as Bash script has that I'm trying to replace right now. For me personally, like the consistency of the language, like everything has its own kind of syntax, and in order to do something, which is like, it feels like it has a bunch of stuff that programming languages has, but it's like each thing has its own syntax. So here we just check if this, actually we always need to get the current one. If we don't have, so if we don't have a length, I guess if length is, so this is, okay, this is maybe length. If we don't have maybe length, we will actually okay, then we can just continue. I forgot we can do this. We can just do continue, right? But if we have an expected length, and then if the expected length is equal or not equal to length, then we have an error. So then we have like well, we don't have this error. This is gonna be like I don't know, 4 sources, different lengths or something like that. Okay, otherwise we're just gonna continue. But if expected length, let's see, if we don't have expected length, we can set expected length to be expected length or else length. So we're kind of updating length. If it's null, we update it to this. If it's not null, we just keep the same value. I wonder if there's like or else equal. Is that, does that work? No. Because it's kind of like a binary operator here. You know, maybe this works. That would be cool. I might have something like this in my language. Yeah, it's not that common. This is like the first time I'm actually having this expression here, but well, maybe it will become more uncommon. Or common, I mean. But then if we have an expected length, we want to match them there. Actually, you know what? If this is not null, so at here, this has to be not null, right? And this one actually also has to be not null at this point. So we can just say if this if they are not equal, then we continue, because otherwise we just continue if this is null there. So that should work there. Yep. Okay. So we validate that. Now, if we get out here and everything is null, it's also gonna be an error, because then everything, like it's like you have a bunch of ranges like this. So 4, 0, 1, 2, 3 or something like that. This is like, yeah, you have a bunch of ranges, but none of them have an ending value, so we don't know the length here. So, or if you just, you know, if you just have this as well. So that's the case where we have here. So we should return an error, unknown for loop length. There we go. If you init to 0, there, does that work? No. Is that fine considering it's an iterated as? I mean, no, because then it's gonna be an infinite loop. Well, okay. I mean, you could allow it, I guess, if you wanna break at some point. Yeah. Well, okay, you convinced me. Yeah, it does make sense. You just have to be careful. Sure, fine. I guess. Yeah, you could break. That is true. You just have to be careful there. I was thinking like we shouldn't allow that at all, but yeah. You can also have while true, except we don't have while troops. While troops? While loops. Okay. Try. So we validate that. Now what we do? We have the sources. We've validated their lengths. Now we will set up. Now we need to like set up the loop, and each iteration we need to like make a scope where these two are available. So we have the values. Maybe we should get the length here, actually. We should get the length out of this, to be honest. No, wait, we could get here for if... Oh yeah, so if this is null, that means we have infinite length. So basically, yeah, if we have infinite length, we should do question mark. So we just return the expected length here. Because we need to support that in that case. Infinite loop, but what infinite loop of what? Do you mean if you just have like a for like this? But what? Okay. I guess you wouldn't capture anything here, and you don't care about the. This is so this is a while true. I mean, technically this is also a while true, except you get the number as well. Except it fails when it overflows, so not great. Just wanted to say, how do you really gain XP here on the live chat? I have no idea. Sorry. Can you do that? I didn't know that how that works. Okay, let's see if we can make this work here. So we got the validate, we got the length. It can be infinite. I guess we could have two different branches here. We can have, if we have a length, then we will for loop. We will execute the for loop with the length. And we get the I. Otherwise, because I don't think, yeah, it's gonna be hard to maybe do this without having two branches. Otherwise, we do this. Now, is this legal? No. We actually get an error in Zig for this. It's unbounded. Oh, that's a nice name for it, actually. Unbounded, but there's no reason really for unless it's for safety. But I mean, Zig does it. Okay, well, you know, you can do this while true. Actually, what the hell? What am I doing? I just use a while loop instead. Use size while true. Continuation expression. And if length, I guess it's because, yeah, we have a branch here now at every turn, but whatever. If we got length, and if I is more than or equal to length, I guess we can do this. Then we continue, otherwise we break. Yeah. There we go. All right. Now, what's gonna happen here? First, we need to set up the scope. New scope with the bindings bound that we need from the sources. And then we just execute the 4-body block with the scope. So that's basically what we need to do here. So the thing is, I don't think we can actually send in stuff to the block. The block, let's say we run block in on context. This is how you get, like, you get a value out from that. So result is that, but the value is not really used, so I'm just gonna deinitialize it. Actually, is it used or is it not used? Doesn't this... oh yeah, this produces a process handle, that's right. This is kind of weird. Like, actually, you know what? We should actually... this result needs to be processed into the parent context. But usually that means it breaks out here, and this expression is then where is that? It is used everywhere, but execute expression, no, execute statement. Yeah, so what's happening here? No, wait, where is that happening? Here, right, execute. This is like the whole script execution. Except for blocks as well. So basically, when a statement is done, we get the value out, it goes in here, and then we forward it to, you know, standard output, standard error. So this would have to be handled, I think. Yeah, it's gonna be like an array of process handles actually. So we could actually do like array and probably need this, I guess. Maybe, no, maybe not. And then array, we will get the thing. And now we have to kind of loop through and do this switch like recursively here. So I would have to make a function here that is like handle forward forward handle output if process handle or something like that. Where is that happening? Utils. Okay, so we need the value and the standard out, standard. Okay. Actually, let's just pass the options. So handle is process handle. And I'm kind of moving ahead a little bit here, but exit code? No, wait. Let's just do void. What do I have here? No, nothing. So I will do this, move this over here, and then we call what was it called? Forward Do we have self here anywhere? No. So this one, the handle is... No, we don't get a handle, we get a value. And options. Could you not use a label in the switch? Yes. Yeah, sorry, I moved forward a little bit. Oh yeah, you mean this one? Oh. Yes. Maybe, but then this is an array, so I have to... I don't know if you can like put an array in there. Also you need the same type. Like I need to do this for every item in the array. Okay, hang on. I'll just do this. Wait, we don't have, yes we do. Interpreter, there we go. UR value. Consumed. Oh, I see. Let's just return a bool. Oh, you need the code. I guess we'll return like an exit code like this. Where is the exit code? Command run an exit code. Match, switch, and then you can use continue match. It's like a state machine. Yeah, okay, but how, like, let's say we have match. And then now we're here. So how do you, like, you take this array, how do you like continue with all items in the array? It's like I can only see how you can continue with one of the items. Like you continue match with items 0, for example. How would you do all the items? Because we have an array, we need to do everything. Yeah. Except you are that, but you're const now. Okay, maybe we don't need this to be mutable. I'm not sure how you do that. Consume through. We return the code. We deinitialize the handle. Sure. What is the issue? Where is the consumed is false. So basically code is this. if code is null, we initialize ourselves, otherwise we get the code and return it, right? But what was it? Otherwise it's from process 1. If we didn't get it. Okay, fine. Yeah, you would have to handle it as a single value. Yeah, but at any point, like, how would you then loop through the array using that? Like, how? Like, this is a single, this is treated as a single value, except it's an array. So we have a bunch of items now in this value. That's these items. So how would you get all of these in here? And that's why I used a recursive call here to fix the problem. Because I want to go through the same process for each of these values. So this value is like a like a generic. It can be a lot of different things. So this switch will look at the thing and it will see if it's a process handle, it handles it. But if it's an array, like, you can't have a loop and then continue like a bunch of times, right? So you have to do this, right? No, then we just return that, yeah. Okay. Local variables never mutate. Oh, I see. You need to do this and then return code because we're using it here. Okay. No, there we go. I mean, couldn't we just do this, like put the defer here, or just not defer, and then we get the code here? Not deferring? Crazy. There we go. Owned equals value. I mean, okay. Oh, I see. So this is just a copy now. Fine. Okay, but then we can put this in as a pointer if we need it to be. There we go. It doesn't really matter that much. Okay. So, but the only problem here is now is like, okay, what do we do with a bunch of exit codes here? If we have an array of process handlers, do we even forward those exit codes? I don't think so. I think we just ignore it. All right. Anyway, that was the issue that I was thinking about, like, because when this body gets executed a bunch of times, what happens with the result of these executions? Like, we need to forward it somewhere, and that's what was happening in here. So this runs a block in its own context, which we should use for the for loop, and it has its own like standard out, standard error. We're running an execution here for the block, and then we have the execution result, which becomes a process handle. But we don't have one; we have like a bunch of them. So basically, I think what we need to do is we need to have a results here, which is one like, so, okay, there's two issues. Basically, we need to forward it back, but also, really, we want probably to have a different flow here that we don't really have currently, because right now the entire statement needs to be completed before the standard out, standard error is forwarded. We need a more streaming fashion where all of the each iteration in the loop will be directly forwarded, and we don't wait until the whole for loop is done until we like forward the standard out. So so we need a little bit of different working there. So basically, when we run this block, we should be able to here be able to forward block result directly somehow, like in a streaming, like we should be able to push the result at this point to the executor, because then we don't have to wait until all of the iterations are done for the thing to end. So I'll show you in a little bit what I mean here, maybe more better. But for now, we need to store the results in an array list of process handles. Actually, they would be values. I think this is a value, right? Oh, yes. So this is a bunch of values. Okay. Now, if we knew the length, we could actually init capacity here. Right, because this is, yeah, if it, yeah. But whatever, it doesn't really matter that much. It's just a little bit of extra allocations that we need. All right, and then at the end, let's deinitialize for safety. Now, yeah, standard out should be streaming. I agree. It's just that I don't have support for it yet, and the pipelines does not support streaming standard out yet. But that will be something that I'm gonna work on at some point. Probably when we do kind of more like function stuff. Because we do have functions right now, but they are very rudimentary, very basic. They can't even take arguments right now, so they can just be called as a block, basically. Okay, anyway, so what is happening here? Why is the syntax all messed up? Oh, probably because of this. So the block is going to be the for expression body. Of course, we need to try. And the scopes will actually, we need to push a stack, push a frame here. And then at the end, we are going to pop a frame as well. Oh, god damn it. Well, let's just do it here, I guess. Because it's a try, so you have to. It's kind of annoying when you want to defer something that needs to be tried, because then you can't just do defer try, because you can't try in a defer. So you have to do this. But that's fine. That's fine. In this case, we can just put it here, so that's fine. All right. Now push frame. So what do we also need to do? We need to gather. So we need to make a new scope with the bindings bound from the sources. So we're gonna put them in this frame that we get from here. So now we can say scopes, declare, and it will declare things in that scope. So in the new frame. So so we need to go through, and actually we could do like declare for sources, and I'm just gonna do that like this. Scopes, scope, and then we need sources, and we also need val or bindings, which we don't have apparently. Okay, bindings. I'll just put any type there for now because I'm not sure what this will be. And this will not return anything. Okay, I'll just do this for now so we can get something that doesn't. Okay, so bindings. Defer tries defer. No. Defer is gonna run at every like scope exit, you could say, like every time. So when the scope ends, defer is gonna run. Yeah, and you can't do try because try implies that you need to return another value. So because if there's an error, it returns the error. If it's not an error, it doesn't return the error. And that changes the defer, that changes the return, and that's not allowed. Like you cannot defer return something else. That's not allowed. Where are we? Here. This is not allowed, so you cannot do defer try. But it is, yeah, it's a really good thing. I love defer. It's just it to me it feels like two major functions. It's like you group together initialization and deinitialization, but also deinitialization is now built into every exit point in the scope, so you don't have to repeat yourself if you were using some other noob language. All right. Okay. For streaming standard out. Okay, so how do we do this now? We need the bindings. So I've not even thought about this, so how this should work. So what we have is the bindings. We have the capture clause with a bunch of bindings. So we have a bunch of binding patterns. I think we just pass in this list here. So let's get the bindings. It's gonna be for expression, capture bindings. Declare for sources, try that. There we go. And now we know the type of bindings is gonna be this type here. There we go. All right. Yo, blue. Cat orange whistling is what I can see from here. No funky C label hacks. Okay, I'm not gonna even touch that because I'm not that good at C, so I haven't actually done anything in C. I mean, I have done a lot of C++ a long time ago, and I've seen a lot of C, but I've never like tried to make anything in C. So I'm not gonna. All right. But oh yeah, so but C still has goto, right? I think. So you can do like you can jump. Out of the context where you are. Okay. Yeah, so let's just go through the bindings. What do you have? So so here we switch on the binding, because we can be a bunch of different things, which we don't get, but basically, come on. Identifier, Discord. These two we can just ignore. We don't allow these two. We're only interested in identifier and Discord. It would be cool though if you could have like destructuring in the binding patterns, but yeah. So we have like this. So discard. I mean, discard is pretty easy. We don't do anything. We just don't bind to anything. And then if we get anything else, it's going to be some kind of error, binding, unsupported binding pattern or something. Okay, and then we have the identifier. And that's just an wait. No, there we go. This is just an identifier that we now we don't evaluate. What we do is we just we declare it. So wait, scopes declare identifier name, and the value is gonna be interesting. Mutable is always false for these according to Zig, which is fine. I'm not sure what I'm gonna do with that, but let's just keep it like this. It's easiest. And then I mean, I guess it doesn't really matter. We could declare it false or true. I mean, we don't really have like references right now, so you can't really modify anything anyway. Anyway, that's a future problem. I think I would have to come back to this when we implement things like references and stuff, but all right. Okay, so we declare that. Now we just need to get the value somehow. So how do we get the value? Do we need to know the iteration? Like, do we need some iterator engine for all of these sources actually? It could be that we pass in the actual current values here instead. I mean, that's what we are doing basically. But these are the sources for these are the values of the thing. Let's actually treat these as the elements, sources, elements of the current iteration. So iteration elements. So now we can just say that we need to get the I, and the value is just going to be iteration elements I, and I will solve this somewhere else because we need to be able to get the values, and that's a value, and you you need a pointer for some reason. Why do you need a pointer? Because you want to be able to move it. Okay. So do we clone it then? Yeah, I think we clone it because this scope is gonna get deinitialized. Yeah, so we have to clone it, or we can clone it directly. Let's make sure everything is cloned when it gets in here. Error union signal. All right. Okay, so now what's missing is being able to find these iteration elements. So what I'm thinking is that this is not going to be sources values item. This is going to be iteration elements. And we need to get those. So I think we need to do two things here. We need to be able to create iteration. We need to be able to create iterators for all the sources. So I'm gonna get like a list of iterators for all the sources. So we're gonna do create iterators, create for sources iterators, and the sources are these items here. And then at the end, we will free this. It could be its own struct actually, probably. So let's just deinitialize at the end. And then we pass in, no, we have self already, so that's fine. So we will create that. So we're just, you know, pretending that we have this type here. And then we also need maybe the length. Probably, maybe. Do we need the length or? Sure, let's try putting the length in there as well. Okay, and now here to get the iteration elements, actually I would try here probably. We get the iteration elements. It's gonna be iterators.next. Actually, we could just use it here. We could just use the iterator pattern here instead. And then this would be iteration elements. We don't need to deal with this. We don't need to deal with this. There we go. Push the frame, declare sources, iteration elements with the bindings. And we run this with this block here, or the scopes. And then we're popping that. All right. Then, now we just need to create this iterator. So I'm gonna make a for sources iterator. We're just pushing the problem away more and more. but yeah. So we have an iterator now. We need the sources, which is a list of values, I believe. Yeah. So list of values. We need a next function, which will return a nullable value. No, list of values. That's right. And actually, each one we need to also deinitialize. So I will defer allocator free iteration elements. Okay. Self sources iterator. Now this needs to be a var. Okay, so next, what are we gonna do? We are going to, oh yeah, and I also need the length. So actually it's nullable. So what do we do? We also need the index, current index, which I've seen this pattern, like it's nullable, but we start with 0, and if index is null, we return null. So that's like, we know that we've reached the end. You cannot actually, yeah, then we set index to null. That means we've reached the end. But otherwise, we are going to create an array, or no, we can just do the array straight up. So iteration elements is gonna be no, self. Oh, we actually need an allocator. Okay, well, let's just store the allocator, I guess. And we will say allocator allocate values for sources length. We need one for each. I mean, okay, technically, if you have a binding pattern that discards, you don't need it, but I'm gonna make everything anyway. And this could also be an error now. All right, so we're allocating that. I mean, also, I guess what we could do is, instead of doing an allocator, we could actually just keep an array in here. No, yeah, no, actually, no, yeah, no, yeah. No, let's do this. Let's have iteration elements here. Nullable. Optional. List of values. Set this to null. Yeah. Then, instead of doing this, we will have like an init function which takes an allocator, a length, sources, there we go, and we return a for sources iterator. We will return length is length, sources is sources, index is, we don't need to specify, iteration elements, we don't, yeah, well, okay, we can allocate. No, we can't. Yes, we can. We just allocate here. Values, and we need sources.length. There we go. So we just have one list of those. So then if we have, and then we have the init function will say void self allocator free self iteration elements. Actually, this doesn't need to be nullable. There we go. So now we can free this. We only need one. We don't need to allocate each step, and we don't need to free it here. Now, why are you not working? I removed the allocator. Okay, but we can just add an allocator in the init. That's fine. All right. So now we need to pass that in there, which no, we're not doing here. Pass allocator in there. Okay. So now to this point here, we got all the logistics out of the way there. Now what's gonna happen here? So actually, I think what we need, I'm gonna push the goalpost even further actually, because we need like iterators, like different iterators for each of these things that we have. So what we're gonna do is we are going to create iterators that are kind of generic. Well, they are iterators, yeah, generic iterators that will yield us values. That's kind of what I'm thinking here. So we need iterators, the children iterators basically, that is gonna give us values. So this would be like value iterator. We could do you know, you could do the interface thing, memory alloc thing here, but I'm just gonna do a union enum. So this will be like a value iterator, and we need value iterator. So this is gonna be a union enum. So this is gonna basically support every kind of iterator thing that you're gonna be able to have. Okay, so this is one of those, and then this thing here is gonna be also, we will populate this. Yeah, we have to create it here. So this will be like iterators. It's gonna be try allocator, allocate value iterator, sources length, and then we're gonna loop through all of the iterators. And iterator is going to be set to from sources I. Right, so now we potentially, like, we have a bunch of iterators that can handle the different types of sources that we can have, and then we store them here. So now we have those. Now we need to also free that here. Free up self iterators. And also we need to loop through. And we need to do that with the values as well. No, because the values are always moved. Actually, the values could be... No, the consumer needs to take care of the values. Yeah. Consumer needs to denit. Consumer is going to own the values in iteration elements. The values return. Yeah. There we go. All right. Where was I? Sorry, I was distracted. Yeah, okay. So we get the iterator here, and then we call the init on that. So we need like a the init function here as well, which is just gonna call switch self inline else the init. I guess if it exists, you can also do here like meta has function type of iterator init, then we call it. Okay. Yeah, and then we'll have something. We have like range, you know, range value, like range iterator. We'll have like array iterator, and so on. So there's gonna be like different iterators depending on the type that we have. So we need to like implement these now. So this is gonna have like the range literal or something, or the value. This is gonna have like the value range, and then next function. Let's also have an index, and we return nullable usize. It's always gonna be usize, and then if index, and then otherwise it's gonna be like, you know, index plus equals 1, return index plus range start. Well, actually, we need to check if. I mean, we could also assume that we're not gonna exceed. Well, we can't actually assume that because the length could be infinite. Now, yeah, we're gonna do, so index is always gonna be 0. We're gonna have a convenience function get length. That we might not know. Actually, value range should really have a convenience function here. So end can be self and or else return null, and then we return end negative self start. And I guess plus if inclusive end we plus 1, otherwise 0. Right? So now we can get the length here. We can get length. It's gonna be self range get length. If we don't have a length, then we're just gonna continue going. So, but now we can check like if index is less than. Now, if we have a length, and if index, actually it's gonna be self index here. If self index is less than L, right? Then we continue. No, if it's so we're checking if we want to fail, I think. If it's more than or equal to L, that means we need to exit. So index is null, return null. Yeah, I'll probably have to go here soon. Let's see, but we want to do with, and then we add by 1. So here we actually want to return the actual value, range start plus index. Yeah, that makes sense, right? And that's the range iterator. And then we don't have a deinitialize function on this because we don't have anything to deinitialize. So this won't like call it, and it won't be an error. So great. Now we have the array iterator. Let's copy this. Array also has like known length and stuff, so this will be the array. And we don't need to deinitialize this. Well, actually, should we? The array should be like a ref here that we then release. Yeah. So we have a deinitialize. Or deinitialize. We deinitialize the array. No, this is array iterator. Okay, now array should be, yeah, that's just the length. Get, okay, this can actually error. We will reference that index we don't need to worry about. Where's the init? Okay. So that's low. We get the length, and if we have it, we should have it. It should always be. It should always exist. So we can do this. If the length is, if the index is more than equal to length, we will abort. Otherwise, we return that. But what do we return? So we will return another value. Actually, the value. This might just be a value. Actually, yeah. I think this is. This has to be a value. So here we return an integer. Yeah. And a value there. So let's see. What do we return here though? So this will be, well, this is just going to be like array. Array slice. Array slice and self index. Yeah, we just returned the value there. I would have to think about the references here a little bit, so I think this might be fine. Yeah. Or do we need to create a new reference when we return it? We'll figure it out. Okay, so now another thing that I want to do is I want to add here is I want to do next. So we need a generic next function. And this has this signature, and then we return try switch self inline else iterator next, and there we go. So that will pick the whatever we have and call next on that and return the value. Yo SQF, how's it going? Welcome back. Okay, so then we have that. Now I think I want to add, I'm not sure about the types here, if you have to have error types or if it's gonna be fine on all these next functions, but I guess we'll see. I know that you can have the try kind of modifier for an expression if you don't know if it's gonna have error or not. Then you can have, there's no like compile error that you would have try there. But yeah, we'll see what happens here. So now we have a bunch of iterators that can handle different kinds of values. We store them in this container of iterators that now gives us all the values, except we need to implement this here. But I'm just gonna double check if I did everything that I needed to do here. You initialize, great. Do you actually need to be a pointer? Well, I guess we'll find out. We're creating all the iterators here, and we're doing, oh yeah, we need this one also from source. We need that one. So let's add this as a init function from source, and this would return a value iterator. And this would be like a value. Yeah, so yeah, so we'll just return switch on value. If it's a range, we will create a range iterator. Let's just add a function here for convenience. There we go. Now we can say init, and we need range dot. No, range is fine. Okay, now we have the range iterator, and then we have array. Then we get the array, and we create an array iterator. With the array there. Now the array is refed here, so that's good. And then when this gets initialized, we deref it basically. Okay, cool. Right. Where are we now? We are over. Okay, so we have the from source. So now we have built up all the iterators, and we built up this structure. We have the deinitialize function. The only thing left is the next function now. I think everything else is basically in place. Okay. Yeah. So basically, we just we have self iterator elements. This is our iteration elements. This is where we keep, like, we store all the things, and this is what we return every time. But now we need to build it up. So we're gonna do like we can do self iteration elements, and we get the element here. So this is the value that we need to populate here. Now the question is, actually the values themselves, do we ref them as well? Okay, we'll figure it out. So basically we can now set this to whatever value is going to be iterated from the iterator of this thing. So if we have the I here as well, we're going to do iterators I next, or try to, anyway, whoa, what's going on? Try. So that will give us the value, maybe. If we don't get it, now that's going to be an issue. I guess we just return null in that case. Yeah, if we start to not get items, we have to return like null. So return null, and index is going to be null. Go to sports. All right. Have fun. See ya. There we go. Let's see. Okay, so we have a bunch of like cleanup stuff to do. Must handle all things. Okay, this function handles member expression. Let's not allow that for arrays just yet. Do we have something else? Ranges maybe? Yeah. Oh yeah, this function. I mean, we could just call init on this one directly. So this will be for iterator init, and we need allocator, length, and items. There we go. Try. Declare for sources. Yeah, I don't think we need anything else, so we don't need self here, I guess. And there's a lot of small cleanup things. Oh yeah, if we have anything else, this should be like, this should almost be like an error or something. Return error unsupported iterator. You need to be tried. You also need to be tried. Are we getting there? You need to be tried, I think. Yes. Hello, what is your editor? NeoVim or NVim. And if it's null, we return null. Otherwise, we can unwrap it, so that's fine. What? Oh, it's I64s. Oh my god. Okay, well, they can't be negative, but I'm just gonna do this. Okay, let's actually do the other way around here. And then you, so that's end I64. And then, yeah, that's an error message. And then we will do, well, actually, we will say if end I64 is less than 0 or start less than 0, then we return negative. Invalid negative length or something, or just negative length maybe. Then we have to like int cast that with this. There we go. Oh, okay. End is in cast ends I64 and you are a usize. Start is a usize in cast range start and minus start. Scopes is not used. Wait. Oh, wait. Oh, I see. So, yeah, we don't need this because it's already evaluated. That's right. Do you use Rust too? Yes. What's your opinion compared to Zig? No, I don't. So sorry, I can't have a comp. I just know that Zig is better. Zig's numeric costs. Yeah, it can be a handful sometimes. Usually, I try to just keep everything the same type, so I don't have to deal with that. But in this case, there was a little bit happening there. Cannot enumerate values of type doop-a-doop-a-doop-a-doo. Oh, I need to deref. And we need to do that. Okay, let's fix these other small issues here. Member function expected one argument. Right, let's remove that. This is also unused now. Great. Starting to get down a bit here with issues. Not allowed for this. Okay. Actually, here we can do index. Self-index is or else return null. That's a lot better actually. And now we don't. Whoops. We don't need you. We can use. God damn it. That and. Whenever we need to use the value, we use index. Otherwise, we need to set it. We use self.index. Oh. Actually, range. These should probably be usize. They shouldn't be integers because it doesn't make sense to have a. Does it make sense to have a negative in the range? If you want to iterate from -10, can you do that in Zig actually? Okay, maybe we should allow that. I mean, why not? Okay. Why the hell not? Except it doesn't work because no, I just realized this should actually be an error because I mean we could just do this. -10 to 0 I try. No, what was so let's say like we have a sum. Testing expect equal expected would be right. No, because it starts at 5. There we go. We get a different. Okay, let's do like I64. Type usize cannot represent integer value -5. So you cannot have negative ranges in Zig. Does that mean you can't have negative ranges in Runic? Yes. No, I don't know. Let's just ban it for now. Yeah. I'll just change this into usize because it's gonna get much easier if you just do actually no, let's keep it fine. Let's just say wait, comp time. What's this? Oh, let's do like inclusive is usize. Does that work? No, because this is I64. Oh, sorry. And start. Hello Aditya Kumar, how's it going? I'm doing great. How are you doing? No, I don't know. Let's just do that. Unused local constant. No, you're not. so you are usize. Clone. Clone. Right, so this would be the same as string for arrays. There we go. Ranges, we can just copy straight up. Okay. This means we don't pass in the correct thing. Yeah. Binding value. Binding value. Okay. Now you need to be try as well. Okay, good. That's good. Incompatible types, use size 964. Of course. I mean, let's just do this. Let's just get start use size start. Use size end question mark false and I64. There we go. Now we can get use size start. No. Use size end. No. There we go. Inclusive. Can we do this now, or is it gonna complain here? No. There we go. No. Oh. You can be an error. Both of them can be an error, of course. So try that. Invalid operands to binary expression option. Oh yeah, that's right. So if we don't have an end, we return null. That's right. There we go. There we go. Right. So now we can just call try gets no use size start. Invalid operands a binary expression optional. Well, let's just unwrap. Wait, if we unwrap, do we get the thing? No, I think we have to like if and then do that. Unfortunately, I'm gonna do this. You are not. Oh. Oh my god. Okay, so this actually needs to be a. Wait. Yeah, an I64. Okay, but that's easier because then we can just do int cast, and we don't need to do this. We can just use self direct or start directory now. Okay, fine. Operator not allowed. Okay, let's do the same thing here. Evaluate length. What? But we could just return. Yeah. Unused. Good. Oh. Expect type integer. Right. Actually, expect type. Right. That's right. So I have like expect boolean. We could also have expect integer, for example, which would be value integer, 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 integer. So now we can say expect integer. We don't need to specify. And now this is an integer. There we go. Same thing here. Expect integer. Now, man, there was a lot of cleanup. Results, init, allocate. Wait. We're not done here, actually. The result is not initialized. The result needs to be put into the results. Results, append, results. Yeah. And then at the end we return. Actually we return like a new array, so we will duplicate the results. Okay. What is this? You need a const Or I mean, you need this. That's fine. Materialize string. Well, arrays are not allowed for now. Ranges not allowed for now. Man, it never ends. What is this? Error union is ignored. Try. Or return. Okay, 2 left here. And many more here. Result, local never mutated. Wait, you... Okay, it's never mutated. Didn't I change it to var just now? You don't need it. Okay. Can of course value into length. Okay, we're getting there. You need this. It's const. Okay, well. Why do you need that? Because you deinitialize if it's a handle. The scope is gonna get deinitialized anyway. Wait, what's happening here? Yeah, I don't care about the exit calls. What? Switch value should return. Wait, function with non-void implicitly returns exit code. Where? We have like else return. I see, we could have here, I guess. Okay, let's just fall through instead. Not a function. Code is this or else? No, wait. Oh, I see. Wait. Okay, so we don't do the or else here. We return it. We do it there. Right. Actually, and then here the values, so this value gets initialized, these don't, and that's fine because they are going to get initialized anyway. Okay, good. Now we've got this issue, the binding value. Okay, so now we bring up this and we do zig build f reference trace. Okay, interpret the scope. Script executor 95. Scope deinitialize. Right. So what's the issue here? Everything is properly done. Release. You are a pointer. Pointer to const. So it's probably this one. We get the pointer there, and we call if it exists. Do we need to do this? No. Or do I not put the pointer there? Okay, this might mess up some things, but I guess we'll see. Okay, it builds. Well, you saw that it did work, but we get a whole bunch of leaks. Yay! Alright, let's fix these leaks, and I think that I have to call it for today. If I even have time for that, we'll see. But yeah, the loops work. We don't have a way to create arrays right now, but technically we could iterate over arrays as well. Let's see, 434 evaluator running block context. Right, that's the for expression. Right, 7, 9, 3. Call a plumber. Yeah, we have leaks. So this one gets. So the array, the stuff in the array doesn't get released. Or it could be that the array itself, like the ref to the array, is not properly deinitialized. Actually, when you dupe an array with like or potential RCs in it, shouldn't we dupe the whole thing? That should be like a, well, no, maybe not. No, that would be states like references. Yeah, no, that should work out fine actually. Hopefully. Did not you know you can leak in Zig? Oh really? It happens. That it happens. I mean, the built-in debug allocator has a leak detector. So whenever you allocate something with it and you put the safety mode on, it will report all the things that weren't cleaned up at the end of the program. So it reports all the leaks, which is really nice because then you know that you have leaks and you can see about where the problem is and you can fix it. But of course, the more convoluted your program is, or the more complex your program is, it could be, or the more spaghetti, I guess, your program is, the more difficult it will be to find where it actually happens, like where you should actually take care of the problem, which is kind of the case here. So we do this, like what is the actual let's do runic for loops. Standard out. Okay, so it's the process handles basically that doesn't get taken care of. Which does have a deinitialize. C code, just brush it under a rug. Yeah, that's the thing. I mean, you could technically make an allocator in C that does the exact same thing. Let's see if we can just fix this one. Why is this not called then? Yeah, the result gets put in here, and then it's returned as a part of the value thing, and then it gets put. Then we get it back from the statement. So now we get this value, and then we run it in here, and then we get the array, and we get the things, and we do this for every item in the array. So every process handle that does go out should be initialized. Wait, what was the actual error? Yeah, it leaks. Yeah. Sorry about that. Yeah, I'm checking because I have like 10 minutes left. So I have to leave here soon. I'm not sure if I can fix this. Let's just check where the other ones. This seems to be the exact same place. And this one as well. I mean, it's probably one per loop, right? So let's say we just have one. No. We have like a bunch of them. What if we remove the thing there? Do we get less or just as many? Okay, good. We get just as many. The RC leaked. So there's a ref counter that's not properly clean up. Is it the iterator maybe? Evaluator 799. Is the array duplicated there? That is not cleaned up. Which is weird. It should be cleaned up with the... Oh. With the scope. Yeah, so we have this array and we duplicate it. Now we also have like the iterator, but that's not that's not the same array though. This is a different array. Let's go to scope. Initialize the frame. Initialize the binding. Initialize the mutable, which is a ref, which should then call the initialize on its children, but maybe that's what went wrong now. Let's see if we can do RC, and we have a string, for example. Let's just define a string, because that is kept in RC. So if something goes wrong with RC, then maybe we get the same issue there. No. What about... Oh. What about a block? Oops. Wait, why isn't that shown? Okay, we got a bug now here. This should print out hello. Oh, it does, but it doesn't do it if we do this. Interesting. Huh. That's weird. We only get like the first one. Okay. So we have a bunch of issues to fix, but I'm not gonna have time to look at everything today. So yeah, I'll try to fix up a little bit in the meantime, but I have to go now. So thank you very much for watching here, and